Hello friends, in this second video we will see about distributions and some descriptive statistics. So descriptive statistics is nothing but statistics where like information is shared about the data, and the basic terminologies are variable, experimental unit, a chart, population, sample, parameter and statistic. So variable is the characteristic that is observed over the period of study, and types of variable are qualitative and quantitative. Qualitative are attributes like skin color, hair color, etc., and quantitative are which has number, white blood cell count, platelet count, etc. Types of quantitative variable are continuous variable and discrete variable. If one variable is studied, it is univariate. If two variables are studied, then then it is known as bivariate, and covariance comes into picture when two variables are studied. So experimental unit is the individual object or person on which the variable is measured. Set of measurements is called data or data set, which comprises population and sample. Population is going to be the one where a large amount of data is studied that could even be uncountable, from which the sample is drawn. Sample is a small size of data that is drawn from the population, so it is like a subset. Parameter and statistic. Parameter is the numerical descriptive measure, and statistic is the numerical descriptive measure, but parameter is for population and statistic is for the sample. And continuous and discrete variable. A random variable is a mathematical formalization of a quantity or object which depends on random events. The term random variable can be misleading, as its mathematical definition is not actually random nor a variable, but rather it is a function from possible outcomes. So like as we saw previously in first video, the possible upper sides of a flipped coin, such as heads and tails, in a measurable space. So these are this is what the random variable is. What is the what is the outcome? And the continuous random variable can take on any value within a range and can often be divided into smaller units. Discrete random variable can take on only specific set of values. Example, number of students in a class or a number of cars in a parking lot. Distribution definition. So probability distribution, a distribution refers to a set of all possible values and their corresponding probabilities or frequencies within a data set or a random variable. It provides a way to describe the patterns, tendencies and the variability of the data or outcomes. It can be defined in two ways. Probability distribution. A probability distribution defines the likelihood of different outcomes occurring in a random experiment or process. It specifies the probability associated with each possible value of a random variable. There are two main types of probability distributions: discrete probability distribution and continuous probability distribution. So applies to discrete random variables, and continuous probability distribution applies to continuous random variables. So discrete means which can take on finite or countable number of distinct values. Continuous means which can take on any value within a specified range. So next, if we see frequency distribution. Frequency distribution is a way to organize and summarize data by displaying the frequencies, counts of different values or ranges of values in a dataset. It provides a snapshot of the distribution of values and their occurrences. Discrete frequency distribution lists each distinct value and the number of times it occurs in the dataset. Continuous frequency distribution groups data into intervals or classes and displays the frequencies within each interval. So for example, in probability distribution, in a fair-sided die, the discrete probability distribution assigns a probability of 1/6 to each of the 6 possible outcomes, 1 to 6. In the case of frequency distribution, for a set of exam scores, a discrete frequency distribution might list the scores and the number of students who achieved each score. In both cases, defining a distribution involves specifying how the values are spread or distributed across different outcomes. Probability distributions are fundamental in statistical analysis, helping to make predictions, calculate expectations, and understand the likelihood of various events. Frequency distributions provide a descriptive summary of the data structure and help visualize patterns and trends. Types of curves. So in continuous distribution, usually we come across the curves, these type of curves. So when the curve is going to be symmetrical, it is known as bell-shaped curve. When the curve symmetrical means like when it is divided in the center from the top, it is going to be equal on the both the sides, on the left side and the right side. Mound shaped curve, when the curve is going to be asymmetrical, that is, it does not necessarily imply symmetry. The mound could be skewed to one side, indicating that the tail on the one side is longer than the other. Like here in this case, in the below diagram, if you see the number of discrete events, as the number of discrete event increases, the curve, the function begins to resemble a normal distribution. Probability density, cumulative, and probability mass functions. Probability density function is a probability density function and cumulative distribution function are for mainly it is for continuous random variable, and cumulative distribution function, like first we will see about probability density function. Probability density function, whose value of at any given sample or point in the sample space can be interpreted as providing a relative likelihood that the value of the random variable would be equal to that sample. So when we see in the right side, that is a continuous probability density function, and a box plot is plotted. So box plot we will see in the future video. What is a box plot? For now, box plot is it could be explained simply as the middle, the median is there at the top because it is a symmetrical function, normal distribution. The median is at the center line, and Q1 and Q3 are the quartile ranges. The middle line is quartile 2, and the first line is the quartile 1, and the third line is quartile 3, and the last line from the box. So Q1, Q3 are going to be the box, and after the box, the line is going to represent the range, like 1.5 times the quartile 1 or 1.5 times the quartile 3. So that is going to define the range, that is going to define that range in which there, and whatever is going to lie outside, the values which are going to lie outside are going to be considered as outliers. So that's how the box plot works, and here there are no outliers. So when we see for probability density function, we take the values from a to b, f of x dx. So a to b, that is probability is a less than or equal to x less than or equal to b, equal to continuous, it is an integration of a to b f of x dx. So that's how the probability density function is there, and so I will just repeat, it is a function whose value at any given sample or point in the sample space can be interpreted as providing a relative likelihood that the value of the random variable would be equal to that sample. So next, in probability theory and statistics, cumulative distribution function of a real valued random variable or just a distribution of x evaluated is the probability that will take a value less than or equal to x. So it is a cumulative one. It includes all the values. Probability mass function is a function that gives the probability that a discrete random variable is exactly equal to some value. So in below figure, the probability that x is equal to 1 is 0.2, probability that x is equal to 3 is 0.5, probability that x is equal to 7 is 0.3. Terms related to normal distribution. So head, like normal distribution, mainly like the curves. In the curve, the head and tail. Head is pointed out in the figure. The head, that is going to be the median approximately, and median or mean depending on the symmetry of the curve, because if you see in the top, the head is going to be the median if it is a symmetrical distribution. In the middle figure, if you see, like we can see, there is a skewness, that is it is going to have a long tail. So in that case, the top is going to be the mode, and symmetrical mean median mode are going to be same, and the negative skewness mode is going to be at the top. And so that's how those are the heads depending on the skewness of the curve. And tail is going to be the close to the bounds of the random variable. Like bounds means like near the end of the random variable, where the random variable is going to like end approximately. So upper bound and the lower bound. So here we see that I have pointed out the tail, and the measures of the central tendency, mean median mode, and the measures of dispersion, variance, and standard deviation. These things will come in the next few slides. Symmetry is going to, like as mentioned previously, if the left side and the right side like when it is bisected at the center, how the left side and the right side is going to resemble, or whether they are going to resemble each other or they are going to differ from one another. And skewness is a measure to the extent to which probability mass function or probability density function leads to one side of its mean. The third, standardized moment of the distribution. Like standardized moment will come in another series of video. Kurtosis is the measure of fatness of the tails of probability mass function or probability density function. So as we can see in this figure, the kurtosis is like a fat. Here in the below figure it is fat, whereas in the figure at the top it is very lean. That very top it is very lean, the kurtosis. This is a probability density function for selected distributions with mean 0 and variance 1 and a different excess kurtosis. So each case the kurtosis is in like a excess. So whether like it can, the kurtosis also will be covered soon in another video. So this is basic definition only. And measures of central tendencies. So measures of central tendency, these are Pythagorean means. Arithmetic mean, geometric mean, and harmonic mean. In probability statistics we will only see about arithmetic mean. So arithmetic mean is the average of all the values. It is pointed out in the right side. The notation and then example how the arithmetic mean is. For geometric mean, if you see the multiplication values, it is square root. Like if there are only two numbers, square root of square root of the multiplication of the two numbers. And if it is going to be having n values, n xn up to xn means it is raised to the power of that n, power 1n, like reciprocal of that number. So geometric values example is given, and harmonic mean can be expressed as the. So in order to understand the harmonic mean, the bracket parenthesis has been included, like in computer function. So it is a reciprocal of the arithmetic mean of the reciprocals of the given set of observations. So first we will see the innermost bracket reciprocal of the given set of observations, or here in the denominator 1 by x1, 1 by x2 up to 1 by xn, and arithmetic mean of the reciprocals. So a of those the reciprocals, and this reciprocal is going to be the harmonic mean. So that is 1 by a of this. This is going to be the harmonic mean. Geometric mean and harmonic mean are going to be used in rates whenever we deal with rates. Arithmetic or financial calculations we will use, and arithmetic mean we use mostly for distributions, normal distribution. And expected value or the mean of the random variable. The formula for the expected value of discrete random variable is sigma xi into probability of xi. So if it is going to be continuous random variable, minus infinity to plus infinity, x into f of x dx, the probability density function. F of x is the probability density function. So this is going to be the expected value. So this can also be told as a weighted average of the probabilities, and it is the mean of the random variable. So it helps in quantifying the long-term behavior of the random variable, which could be recovery from a disease due to drug dosage, as in clinical trial. So the right side thing I explained just now. And the measures of central tendency again continued, median and mode. Previously till now we saw about last 2 slides we saw about mean. Here we are seeing about median and mode. Median is the robust measure of central tendency and is often used when dealing with skewed distributions or data sets containing outliers. So it represents the middle value, making it less influenced by extreme values. It is particularly useful when data is not normally distributed, not symmetric. So not normally distributed means that is not symmetric. Bell-shaped probability distribution, but asymmetric bell-shaped. So like mound-shaped, mound curve, which we saw previously. So mode identifies the most frequently occurring value in dataset. In probability and statistics, the mode is useful for describing the central value in categorical or discrete datasets. So it is the most frequently occurring. So consider some datasets may have multiple modes, multimodal. If it has only one mode, it is unimodal, and if it has two modes, it is bimodal, or no modes at all. In the above figure, the skewness we like what is positive skewness and what is negative skewness and what is symmetrical distribution. So positive skewness has a long right tail and negative skewness has a long left tail. The distribution can still have zero near skewness and not be perfectly symmetric like middle figure. It can resemble like a middle figure, but it cannot be perfectly symmetric and can have near zero skewness. So skewness and symmetric need not be like we cannot know from the exactly, they are not perfectly correlated. It can have some small deviations from symmetry. So measures of dispersion means spread or variability of the data. So range, interquartile range, variance, mean square error, mean absolute deviation, coefficient of variation, z square. So these are the measures of dispersion. Range is going to be the minimum maximum value minus the minimum value in the data set. Mean range and median range, where there are subsets of data, range for the median and mean are found. Interquartile range means middle 50% of the data. So I explained about interquartile range previously. We saw in like a couple of minutes back. I might have explained that. And variance is going to be the average of the squared deviations of each data point from the mean. And the formula for variance is explained here in the right side. So standard deviation is most commonly used because it explains the interpretability of the data in the original units of the data. It is a square root of variance. Mean squared error, average squared difference between observed and predicted values. It is often used in the context of regression analysis. Mean absolute deviation, average of the absolute differences between each data point and the mean. It is less sensitive to extreme values than standard deviation. So the formula for it is E of x minus mu. Coefficient of variation, ratio of the standard deviation sigma to the mean mu, used to express relative variability of a set. It is used in many places. For example, it is used in analytical chemistry, allowing for comparison between different data sets. Percentile divides the data set into 100th, 25th and 50th percentile, can be used to understand spread of data at different levels. Z score measures how many standard deviations a data point is from the mean. So Z is equal to x minus mu by sigma. It is useful for identifying outliers. So discrete distributions, types of commonly referred discrete distribution is discrete is a uniform distribution. Every event has an equal chance of occurring. Bernoulli distribution, binomial distribution, and Poisson distribution are some types of discrete distribution. And Bernoulli distribution is less formally, it can be thought of as a model of the possible set of possible outcomes of any single experiment that asks as a yes or no question. Models probability p of success and 1 minus p of failure. Binomial distribution describes the success of a fixed number of independent trials used with two possible outcomes like heads or tails. In probability theory and statistics, the binomial distribution with parameters n and p, n is the number of like events, and p is the probability of success, is the discrete probability distribution of the number of success in a sequence of n independent experiments, and each asking a yes or no question, each with its own boolean set of boolean valued outcome. And failure means 1 minus p, or it is represented as q. Poisson distribution models the number of events that occur in a fixed interval of time or space. Number of events that occur in a fixed interval or space. It's often used for rare events with a known average rate. There are few more like geometric, hypergeometric, discrete logarithmic, and Zipf's law distributions, which are all discrete distributions. Continuous distributions are normal distribution, uniform distribution, exponential distribution, logistic distribution, gamma distribution, Cauchy distribution, Weibull distribution. So each one's description is given, and each normal distribution has been discussed previously, and other types of distribution we will see soon. Now for the moment we can see uniform distribution, all values within a given range are equally likely, and useful for modeling situations where each outcome is equally likely. That's what was mentioned. Exponential distribution. The exponential distribution describes the time between events in a Poisson process, so where events occur continuously and independently at a constant rate. Applications commonly used in reliability engineering to model the time until failure of a system. Logistic distribution. The logistic distribution is S-shaped and is characterized by its location, mu, and scale sigma parameters. Mu is mean, and scale sigma is standard deviation parameters. It is often used in logistic regression and modeling growth processes. Widely used in statistics and machine learning for binary classification problems. Gamma distribution is a generalization of the exponential distribution and includes two parameters, kappa and theta. Commonly used in reliability engineering and queuing theory, modeling the waiting time until the events occur in a Poisson process. Cauchy distribution. The Cauchy distribution has heavy tails and no defined mean or variance. It is often used in physics and statistical inference. Commonly encountered in physics, that is especially in resonance phenomena, and used in Bayesian statistics. Weibull distribution. The way is flexible and can model a range of shapes, including exponential and normal distributions. It is often used in reliability engineering, commonly used to model time to failure data in reliability engineering and live data analysis. Other types of continuous distribution are chi-square distribution, students t-square distribution, logistic distribution, Pr2 distribution, triangular distribution, Rayleigh distribution, Gumbel distribution. Chi-square, a special case of gamma distribution. It is used in hypothesis testing when comparing with especially in the context of comparing variances. Students t distribution, used in hypothesis testing when the sample size is small and the population standard deviation is unknown. Logistic distribution, S-shaped and symmetric, often used in logistic regression and modeling growth process. Pareto distribution represents power law distributions where a small number of items have disproportionately large impacts, often used in economics and wealth distribution studies. Triangular distribution, defined by a minimum, a maximum, and mode. It is often used in risk analysis and estimation when there is limited information about the distribution. Rayleigh distribution models the distribution of the magnitude of the two-dimensional vector whose components are independent and identically distributed Gaussian variables. Gumbel distribution used to model extreme value distributions such as maximum values of river flows or earthquake magnitudes. So an example using Minitab is a software. This is a statistical software package like SAS and SAS and SPSS. So when we go to this menu, start basic studies, basic statistics, and display descriptive statistics. After entering the data, we get an outcome. We see the outcome like this. So there are many other statistical packages. We can get all these kind of these are all descriptive statistics. So we are seeing the mean, median, mode, minimum, maximum, quartile 1, quartile 3, and standard error. So standard error, SE mean, that is standard error mean. So the formula for standard error mean was discussed previously, that is sigma by sorry, it was not discussed previously. Standard error mean is standard deviation by square root of n. I can just messed up with another formula. So this is standard error mean, standard error of the mean, standard deviation by square root of n, where n is the number of data. Standard deviation is equal to square root of variance, and quartiles, interquartile range was discussed previously. Variance is equal to formula we saw previously again, E of x minus mu by the whole square. Standard deviation is square root of variance. So all these values will come in the statistical package, whichever sort of statistical package. And with this, this video ends. Thanks.